The directions for this example are to use the factor theorem to determine if the binomials given are factors of f of x. So, at least for the first part of the directions, we're going to take a look at this given polynomial, and we're going to see if x minus 2 is a factor of that. We also want to see if x plus 5 is a factor of that. What the factor theorem says is, if you have something that is a factor of something else, when you divide it, you will get a remainder of 0. So we're going to go through and do some division. We'll take our polynomial and we'll divide by x minus 2, and if we get a remainder of 0, then we know x minus 2 is a factor. And if we get any other number for the remainder, then we know x minus 2 is not a factor. And we'll do the same thing with the x plus 5. You could use synthetic or long division for this problem. I'm going to choose to use synthetic division. So here is our original. It is a 3x cubed minus x squared minus 22x plus 24. And what I want to do is I want to see if we use some synthetic division, if we get a remainder of 0 or not. When I take a look at our polynomial, we have an x cubed term, an x squared term, and a 24, just a plain number. We're not missing any of our powers of x there, so we don't need any zeros to hold those places. So I'm going to use 3, negative 1, negative 22, and 24 for my numbers. And then out here in front, if we are going to see if x minus 2 is a factor or not, we would put a positive 2 out in front. Remember that when you go through and you're determining what this number is in front, you basically take what's here and you set it equal to 0. So x minus 2 equals 0 would be the equation that you're trying to solve. And when you go through and solve that, we do end up with 2. So x minus 2 equals 0. That is what we would want to take a look at and solve. So if you add 2 on both sides, you would get x is equal to 2. That is why we put that positive 2 in front. The synthetic division process, first we do 3. There's nothing underneath it, so that's 3 plus 0, which is 3. Then from there, you want to take that number that you just wrote down in the bottom, you multiply that by the value in front. 3 times 2 is 6, and you put that under the next number. If this number here ends up being positive, like this one is, then you're going to add. So we're going to do a negative 1 plus 6. And if this were a negative here, then we'd be doing subtraction. But it is a positive, so negative 1 plus 6 is what we have for that one. And the answer to that is 5. I just wrote a number in the bottom, so I'm going to multiply by that number in front again. 5 times 2 is 10, and I put that in the next column. This is a positive, so I'm going to do negative 22 plus 10, which gives me a negative 12. 2 times negative 12 is negative 24. I have a negative this time, so I'm going to do some subtraction, and 24 minus 24 is 0. I'll put a vertical line here between the last number and the one in front of it. This last number here is our remainder. These values in front represent a depressed polynomial, is what they call it. And from there, we will need to determine, first of all, if we have a factor. And if we do, then we'll need to do some factoring. The second part of the directions say to use the binomials that are to write the factored form. So here is our original. I did synthetic division, and I did get a remainder of 0 when I divided by 2, which comes from that x minus 2 as a possible factor. So this means, because we got a remainder of 0, that x minus 2 is a factor. That's the conclusion that we have from that work. That's what that tells me. So what I can do now is I can take the original and I can rewrite that using some factors. And x minus 2 would be one of the factors, and then I use these numbers to get the other set of parentheses. This last digit is a constant term here, which means this is an x and this is an x squared term. So 3x squared plus 5x minus 12 is how we would go through and factor the original. So here's our original. We wanted to see if x minus 2 is a factor, so we divided by 2. We see we get a remainder of 0. Because of that, we know that x minus 2 is a factor, and the other factor would be a 3x squared plus 5x minus 12. Next, we want to take what is here and see if x plus 5 is a factor. So we're going to go through and do a similar process. If you end up with a factor here, you can use this depressed polynomial in your next step. That will make the work a little bit easier. So I'm going to do synthetic division again, but the numbers I'm going to use are from the depressed polynomial because it did end up being a factor. So I'm going to do synthetic division again, using a 3 and a 5 and a negative 12 to see if this factors. This time I want to see if an x plus 5 is a factor, which means if I do x plus 5 equals 0, and then solve that, what we are dividing by out in front is a negative 5. From there we do our synthetic division steps. 3 plus nothing is 3. That 3 times the negative 5 in front gives us a negative 15. 5 minus 15 is a negative 10. That negative 10 times that negative 5 is a positive 50. And negative 12 plus 50 is a positive 38. The last number is always the remainder. So when I did the division this time, I ended up with a remainder of 38. That means that x plus 5 is not a factor. The only time you get a factor is if you get a remainder of 0. Any other number does not give you a factor. So we know that x minus 2 is a factor because when we divided by 2, we ended up with a remainder of 0. That allowed us to do some factoring. Then we tried x plus 5 by dividing by a negative 5. When I did that, the remainder ended up being 38. So that means that x plus 5 is not a factor. We want to use the binomials that are to write a factored form of f of x. We have done that once already because we ended up with a remainder of 0 here, but we should check and see if we can factor this anymore. So the flow of this problem, here's our original. We divided by 2 to see if x minus 2 is a factor, and it was. So we were able to rewrite the original using 2 factors. Now we wanted to see if x plus 5 was a factor, so we did some more synthetic division. We ended up with a remainder of 38 this time, so using that we know that x plus 5 is not a factor. But what I do want to do is I want to take this, and I do want to factor it some more if we can. I don't know if we'll be able to or not, but we'll use our old factoring skills rather than synthetic division to see if we can factor this anymore. The only factors that they wanted us to check were x minus 2 and x plus 5, and I have checked those. So we didn't end up with a remainder of 0, so I'm using the same factors we had before, and I want to see if these factor anymore. This x plus 2 is done. It's a 2-term polynomial and doesn't fit any of our rules for 2 terms. We have an addition in between, so the only option would be sum of cubes, and 2 is not a perfect cube. I do have a trinomial here, though, so let me run through my factoring there. First thing I want to do is factor out what's in common. We don't have anything in common. Then from there, we count terms, and with 3 of them, we would be doing the add-multiply method. So I am looking for a pair of numbers that add to be this middle coefficient, so I want them to add to be 5. And multiply to be the last number times the first one. So a negative 12 times 3, which is a negative 36. So if I can find a pair of numbers that fits that pattern, then we will be able to factor this trinomial some more. And there are a couple of numbers that do that, positive 9 and negative 4. So I am going to be able to do some more factoring. This trinomial will factor using our add-multiply method. I can't use the shortcut because I have a 3 in front of the x squared. We can only do the shortcut if we have a 1x squared. So our steps, we copy this first term down again. That's a 3x squared. And then we split the middle term up into 2 parts using these 2 numbers. So the 9x, or the 5x that's here, we're going to break into a 9x minus 4x. and then we copy that last term down again. That gives us a 4-term polynomial, and now we can go through and do factoring by grouping and try to get some matching parentheses. These first two terms here, they have a 3x in common. If I factor a 3x in common, I end up with an x plus 3. These last two terms have a 4 in common. I can factor out either a positive or a negative 4, and I'm going to choose a negative 4 because this first term here in this last group is a negative. So I'm going to factor a negative 4 out in front. And if I do that, I end up with an x plus 3. I do have matching parentheses here, which means that this does factor. One of our sets of parentheses will be the matched set, the x plus 3, and the other is what we factored in front, which is a 3x minus 4. So the 3x squared plus 5x minus 12, that trinomial, that factored into an x plus 3 times a 3x minus 4. But remember, we did have that x plus 2 out in front also. So we have one more factor that we need to write down, and our final answer here for this problem is a factor of x plus 2, a factor of x plus 3, and a factor of 3x minus 4. Now it is in completely factored form. Going back to the directions for a second. We're supposed to use the factor theorem to determine if the binomials given are factors. The x minus 2 was, yes, that was a factor. The x plus 5 was not. No, it was not. When we did go through and do a little factoring, we were able to break this all the way down into an x plus 2, x plus 3, and a 3x minus 4. What you're going to see in the back of the book for solutions on this is this. First, we check to see if x minus 2 was a factor because that was our first one that was listed here, and it was. Then we check to see if x plus 5 was a factor. We did not get a remainder of 0, so it was not. And then we went through and we did more factoring, and we ended up with a final factored form of x plus 2, x plus 3, and a 3x minus 4. Let me rewrite that again. That got a little squished. X plus 2, and now I just can't write. I'll erase it, start over. Okay, here we go. F of x is equal to our factors, an x plus 2, an x plus 3, and a 3x minus 4. And now I fit it in before we hit the edge. So when you give your answers, you have to answer the questions. Is the first factor a factor? Yes, it was. Is the second factor listed a factor? No, it's not. And then give your final factored form on that. If you end up with no and no for your two answers, then you don't need to do any factoring at all.